Okay, okay. Alright, that was a short-lived 2-day streak. We're gonna have to break it up here, I think. Minimum distance to type a word using 2 fingers. Okay, hard. Minimum distance. Okay. You have a keyboard layout as shown above the XY plane where each English uppercase letter is located at some coordinate. For example, the letter A is located at coordinate 0, 0, B is coordinate 0, 1, so X, Y. The letter P is located in 2, 3, 2, 0, 1, 2, X, Y. I think this is row column actually, right? B is located in 0, 1, row 0, column 1. So it's not really... Okay, so it's XY plane, but the coordinates here are row column. Okay. And Z is located at coordinate 4, 1, row 4, column 1. Okay. Given the string word, return the minimum total distance to type such string using only 2 fingers. Using only 2 fingers. Note that the initial positions of your 2 fingers are considered free, so do not count towards your total distance. Also, your 2 fingers do not have to start the first letter or the first 2 letters. Okay, so you kind of have this is a funny setup. I think I can easily kind of visualize what's going on, but like you can have 2 kind of starting points for where your fingers are. I'm wondering how they calculate distance though. Is it like, is the distance... Okay, the distance is the change, it's the absolute value of the difference in x and difference in y, so it's not, it's like walking on a block distance where you can only go north, east, south, west on any block. Okay, that's fine. That's probably a lot easier than using like n squared distance or something. So the word cake, C-A-K-E, so you probably start with C and K as where your letters are, where your fingers are. So it'd be 0, 2, and then 0, 1, so it'd be 3, right? Okay. Happy, H-A-P-P-Y. So I assume you want a finger on H, so H, A would cost you 2, another finger on P, so that'd be 0, another P would be 0, and then the last Y you'd move the A finger, so 1, 2, 3, 4, so 2 plus 4, which is 6. Okay, okay. Simple enough. This actually doesn't seem that bad. This seems very much like I was about to say this seems like dynamic programming. Because at any given index in the string that you're typing, you have maybe it's not actually. You would probably need to have like for any given index in the string that you're typing, you probably need to have every possible position where your key is, every possible position where both your keys are. So this like 26 and 26 possibilities roughly. That's 26 and 26 is 25, 25 is 625, so 676, something like that. Pretty short string. Maybe this string is even shorter than what I might imagine dynamic programming would allow. So maybe it's something even slower than dynamic programming. Either that, or it could be like literally 300 times 676 or whatever. For every position. Get your so your fingers at any given time are either not on the keyboard or they're on one of the letters of the string, right? So it's not like it's so there's only so maybe even it's not even 26 times 26 possibilities. It's more like maybe indices that are involved. So for any so let's say your two fingers are on the string or on the keyboard have been placed there, then at that point for any new letter that you're typing, you're moving one of those two keys. You're moving one of those two keys to the latest one. Backtracking maybe? Happy. Happy. So you have H. Well, the first letter has to be a key, right? Like there's just there's no possibility where your first finger isn't on the first letter of the string. So really at that point, it's like when do you have a letter where you put in your second finger, and then also maybe if you know what your two fingers are on, what is the shortest distance? I guess it's like once your two fingers are on, there's nothing more dynamic than that, right? Like there's no more decisions. The remaining string has some sort of minimum path that you need to do. So that minimum path, I don't know how long it would take. It might take a long time, but it might not to figure out. So at any given point, you're minimizing like one finger doing everything versus one finger plus the new finger doing everything. So it's like you place your first finger on the keyboard, and then for every subsequent letter, you determine whether or not you want to place your second finger on the keyboard for typing that letter. And then once that second finger is on there, then it's then it should just be a matter of figuring out what the minimum path is to use those two fingers that are on the keyboard to move around. Actually, if I trace backwards, right? Can I trace backwards? H-A-P-P-Y. So if I go Y, so one finger has to be on the Y. And then P. I wonder if considering typing the string backwards is equivalent to typing it forwards. Y, P. So either Y moved from the P, or Y is something before the P, and Y and P are separate. And then A, Y, the finger that typed Y goes to A. Finger that typed A. So let's go through some notes. And second finger. So kind of let's see. How should yes. I'm not sure how to describe this. Realizations, conclusions, requirements. So conclusions. Okay. First finger must type first letter. Once second finger comes into play, should be a fixed calculation to find the minimum distance to type remaining string, in the sense that there should be, yeah, it's like a fixed calculation. Can work backwards, type string backwards to get same result. Okay, so those are my points. Okay, so if I know that my second finger has entered typing the string, and I know where my two fingers are, what letters they are, how quickly can I determine the short path to type after? So yeah, how to determine the shortest path to type remaining string given where current fingers are. Hopefully ideally this is O of n time. Because if this is O of n time to type the remaining string given where the fingers are, then it's like O of n times, it'd be O of n times O of n to figure out, to kind of place the second finger on, then that finger being on there. What the ideal thing is. Kind of goes back to dynamic programming, maybe. Once the two fingers are on the same keys at any given point, it's the same calculation later on. Y P P A H. Y P. So I know that Y has the finger. Maybe it's dynamic programming once I have my two fingers. Y, say the Y is 1, the P is 2. Should I always be using the should always be using the shortest? Should always be using the shortest? So let's say so like P and Y to A. Would it ever make sense for P to be moving to A instead of Y? Even though Y is closer to A? I guess it was something like it was A, Z, A, Z. In which case P should go to A and then Y should stay here and go to Z next. H-A-P-P-Y, H-A-P-P-Y. H goes to A. In theory, you can have a second finger A. There's different possible strings that lead you to that. Let's say it's H-A. In theory, maybe not easy. In theory, though. So once you have your two fingers on the keyboard, every subsequent key needs to move. Every subsequent key needs to use finger 1 or finger 2. Every subsequent key needs to use finger 1 or 2. I wonder if it's similar to encoding the string in a binary, where the binary is 0, 1 for the finger that's being used to type that string. Type that letter in the string. I don't think that helps at all. H, so 0, 0, 1, 1, 0. 0 is like the left finger and P's, and 1 is the right finger typing it. 0, 0, 1, 0. Type this. Type this. Type this. Total distance is 2. If I'm using the same finger, total distance is 0 if I'm using a second finger. And then P. I think there's two possibilities. One is to start the second finger on P. Another is move the H to P. The other one is to move the A to P. So there's three possibilities there. O of n time to do the calculation. Where is it possible? You know where your two fingers are, and then every subsequent letter you're moving with left or right finger onto it, calculating the distance for that move. I guess at any given time, one finger is on the last letter that was typed, and then the other finger is on one of the remaining 25 letters. So I wonder if I can narrow it down to 25 possibilities, because I know that one finger is on the last letter that was typed. So the question is where the other finger is. I guess there's 26 possibilities because it could be 25 other letters or not on, or maybe the finger hasn't been used yet. So it's like 26 possibilities. Huh. That would make it a lot easier to do dynamic programming if I only had 26 kind of possible previous states to transition from, where the transition occurs. Would that work? Would that work? Okay, I think maybe I'm going to try a dynamic approach here. So TP is going to be, let's say n is the length of the word. And then dp is going to be, so it's going to be 26 possibilities, 26 possible placements. So I think the default should be the total cost is infinite or 0. I want to minimize the total cost. So I think I start with infinite times 27. Normally there's like +1, but maybe it's only 26 here. 26 for everything in range n +1. Okay, so this is going to be the dynamic programming matrix here. So for dynamic programming, we always think about it in terms of kind of Turing machines. So it's the state is the state kind of inputs or parameters is going to be corresponding to the dimensions of the matrix. So it needs to have it for the index of string, what letter you're typing, and kind of the other placement of other finger. Where one finger must be on previous must be on letter of previous index. So those are the two dimensions. And then the state kind of value or state output would be the lowest cost to get to this state, to get to this particular index with some prior placement of fingers. Okay. So generally I find that we generally need to initialize the first value in the dynamic programming matrix differently than the rest, because it's otherwise there's no initial conditions that you're working on. So basically at index 0, the cost should be 0. I think I need the first letter of the string. So I think I want to convert the string into maybe numbers. Yeah, like A becomes 0. I can convert that to 0 through, yeah, A0 be the 1, something like that. So let's say word is going to convert using a list comprehension to ordinal of the letter K minus the offset, where the offset is, actually maybe I can convert it using int. Can I convert it using int? Can I convert it using like A minus A? Offset is ordinal A, ordinal capital A. For every K in the original word, for every, I think that might be right. Okay, happy 70 15 15 24. 25 would be Z, where A is 0, so that seems right. Okay, yeah. Cakes, C, A, K, B, that's fine. Okay, so dp of 0, I think dp of 0 of the letter A, or the first letter in the string. So the first letter is going to be word of 0 equals 0. So that's to say that the cost of placing my first finger on the first letter and typing it as my 0. And then, so I type H, this costs 0, move to the next index, index 1, letter A, and yeah. Is that right? So with infinity, the other costs, other ones haven't been placed. So it's infinity. Infinity must mean that it hasn't been placed yet. I don't think infinity works here, to be honest. Might be just strictly invalid. I guess infinity could count as being valid, depending on how I want to use the logic. -1. Maybe it needs to be 27, to be honest. So I want maybe like the 26 index to be haven't been placed. 26 index haven't been placed. If that makes sense. Hasn't been placed. Okay, I'm gonna do the easier stuff. This is the harder stuff. Okay, let's just try code and see where it goes. For every index in range n1 to n plus 1, let's say the letter is word at this index. So I typed H with my first finger, and now I need to say A's can be typed using that as the news finger, the second finger for moving the H. So placement of the other finger. Placement of the other finger. One must be on the previous index. One is on the previous index, or this is the second placement. Right? Because no, that's not right. So move H. Move the transition to a state where my two fingers are H and A, or A and blank, blank being not placed yet. Transitioning from this state where one finger's on H. So one finger's on H, other fingers on the unknown letter. None of the other ones should be valid. So no, all the other ones should be -1. So one fingers on one fingers on H. The last finger this type is H. Index of a string. Placement of the other finger. So the placement of the other finger is either going to be unknown. Yeah, you better maybe try and draw diagrams of the states of the Turing machine. And transitioning from so index 0, placement of a blank. So one finger must be on the letter previous index. H and blank. Zero H 0. So what's my next date that I want to transition to? 1, the last placement of the other finger. So at 1, I either have it placement of the other finger is maybe I'm doing this wrong. Maybe I'm doing this wrong. As if there was any chance I was doing it right. I wonder if this should be 0 unknown to say that this is a new finger placed. So it's like A through Z plus unknown is kind of dimension. And then like maybe 1 and A, last finger. So H has to be one of the fingers. H has to be one of the fingers. Right? On the first type, H has to be one of the fingers. And the placement of the other finger has to be unknown. Right? So maybe it should be like the last thing here, which is maybe index -1 for last stuff. Which is to say that one finger has to be on the letter H because that's the first letter in the string. And the other finger is somewhere random, somewhere to be determined. So maybe -1. And then the second that transitions to index 1, typing A. I'm typing A, one finger is on A, and the other finger is either on H, because A is like H and A are where the two fingers are, or the other finger is on -1 for not being placed yet. So it's like 1H is the other one, or 1 -1. Because A has to be there. Okay. And if it was 1H, then that means that I typed A with one letter with one finger and H with the other finger, so this has to be 0. This should have a cost of 0 for doing this. Or if I typed H and then A, still having the other finger be unplaced, and this should be 2. -1 indicates unplaced second finger. And then for the second index, when typing P, it could be that the other finger's on H, or the other finger's on A, or the other finger hasn't been placed. Right. The finger's on. Yeah. Yeah. I think this is doable. I think I could probably do these transitions. Okay. So like I would just need to figure out like transitioning from the state that is this to the lowest cost of transitioning from this state to this state, and store those values with this state to this state. So from every previous possible state to every future possible state. I think. Would that be that? That would be like 5. That'd be 26 times 26, which is 512 transitions, and then 512 times 26 times 26, so it'd be 676, or maybe 27 times 27, which is 8, 729 times 300. Okay, so the first state should be, yeah, dp of 0, -1 is equal to 0. So the letter here is that right? 0, -1 is 0. How do I know so I know that one letter has to be on H. Okay, so this is to type, and then let's say previous letter is the word at index -1, because that's where one finger is at. Or I'll just say previous, and I'll say current letter is going to be word at this index. Seems a little wordy, verbose. So the one finger is on the previous letter. One finger is on the previous letter. And the other finger is on wherever this index is. So for every other possibility in range, I guess this is range 27, where 26 is having not typed and having an unused finger. Every other in range 27. Does that make sense though? That makes sense. So how would I tell when I have, well, how would I tell when I've already used both letters, both fingers? H, A. How would I tell that I've used both fingers? So if I've used both fingers, or how would I tell that I've only used one finger up to now? I've only used one finger up to now. Type H, I type A. Is it just reusing the actual slot of the previous letter? Because I can't have both fingers on the same letter. So can I just reuse that slot to say that that would be the indicator that I haven't used two fingers? So I have one finger on H, the previous letter, and then if I'm using that same slot, then I don't think that works. One H. My second finger hasn't been placed yet. Then by this point, placement of the other finger. One finger's on the last letter typed. One finger's on the last letter typed. Should be able to find a way to do this within the loop, I think. Okay, so the current letter is A, the previous letter is H. Think for every other, if dp of this index and I think maybe this should be for dp of index minus 1 and this other is equal to -1, then continue, which is to say that's not possible. Okay, so current letter is A. The other letter, the other finger is on something that's possible. So the current other is going to be at -1 or 26. So dp of 0, -1 is equal to 0. So for here I need to do the transition for trying to type the current letter given this combination. Trying to type this current letter given this combination. So if I have a finger on H and a finger, the previous is on H, current is A, I can either move my H to type the A, I can move my second finger to type the A. If I move my H to type the A, then move the previous to type. So this other stays the same, right? So this other doesn't move. So this other is the slot where I put this. The other is the place. Okay, I think I need some sort of mapping. Find distance between letter 1 and letter 2. And I think, how should I do this? So alpha is equal to A, B, C, D, E, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, Y, Z. And then let's say I do a mapping of each index to, no, this is stupid. This is stupid. I already converted to integers. So locations is going to be, this is going to be RC for R, so the outer loop, the inner loop should be columns and the outer loop should be rows, I think, for C in range 0 to 6, in range 6, not inclusive, and then for R in range 0, 1, 2, 3, 4, I'm going to say. So hopefully this gives me like 0, 0. Expected indented block vector function. Alright, fine. I haven't finished my function. 0, 0. Whoops, it's not right. Should be 0, 0, 0, 1, 0, 2. So how did this for every column? Huh, I thought that would work the other way around. Okay, so I guess I need to do for every row is the inner. That seems odd to me. Seems backwards. Can't deny the fact that this looks better. Row 0, column 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 1 through 1. Yeah. The only issue is I think this goes too far. 0, 1, 2, 3, 4. Whoops, it doesn't go far enough. Oh, there should be 5 rows, right? But these ones technically should not be there. So I need to either pop it or just not call it correctly. So I think here, do I need to do an error check here? Okay, so let's say R1C1 is equal to locations of letter 1. R2C2 is equal to locations of letter 2. And return the absolute value R2 minus R1 plus absolute value C2 minus C1. I think that's right. And then I'll just do a quick check. Print find distance between, what was it? P was what? Okay, P was 15, Y was 24, so still I just print find distance between 15 and 24. So that's 5, really? Oh yeah, yeah. It's 1, 2, 3. No, that's wrong. It's 4. Oh. Okay, so let's go ahead and just put this out here. Print locations for 15, locations for 24. Is it 24 or 25? 24. Locations. Oh, wait. It's going from, whoops. Okay, it's going from P to Y. So P, 1, 2, 3, 4, 5. Okay, that's right. That's 5. And yeah. Okay, I was thinking Y to A, which would have been not that. Okay, so I have the distance function, helper function. So for every other in range 27, so I need to transition either keeping this letter where it is, this other finger where it is, and then moving the current letter to the new letter. But do I need to do a minimized distance in that case? My other finger's there. Do I need to use minimize? I don't think so. I want to say I need to use an addition. Okay, so for so I guess the question is which finger moves, right? Is it my other finger or my previous finger moves to type the current? There's only two possibilities that I need to worry about within this thing rather than 26. All right. Either previous finger or other finger moves to type current letter. So I want to say dp of index for let's say or the other. So let's say the other is kept constant. So this means this should be equal to let's say the total cost is currently dp of index minus 1 of other. So if I don't move other, then this would be cost plus find distance, moving my previous finger to my current letter. So like find distance of the previous to the current. Otherwise, it's trying to move this thing. So I think if the other is actually on the special, if the other is equal to the special, which is 26, then dp of index of the previous equals 0 somehow. No, it equals cost. So whatever cost it was to get to this point, there's no additional cost. Yeah, this seems a little iffy. Else, it should be dp of index previous is where my other finger is equal to cost plus find distance between the other finger and this current letter. This seems incorrect. Because how do I know that I haven't typed at least 26? That's right though. So how do I get to 26? 26 being my finger being unplaced. So it's unplaced initially. And then other has to be unplaced here. And then I'm going to say that's still 0. That seems Okay, I think this should be previous if other equals 26, and previous always might cover everything. So if my so H to A, so type H, type A is now 2. 2 unknown, 2 unplaced finger, that is right. 2 unplaced finger, 2 unplaced finger, this other finger is unplaced, then now it needs to be placed at this thing, right? DP, so previous fingers there. Maybe that is right. Cost doesn't change. Otherwise, if I have 2 fingers on different keys, then yeah, I'll do this with this. Huh. Okay. Then I should have some sort of min in this. Like there should be multiple ways to transition to a particular state, I would say. So moving to next, moving to type this current index. Maybe it should be infinity. Infinity and lower it. Lower the cost. If the cost is infinity, to get to a particular spot, that's just not possible. Maybe this should be infinity. BP to the next index for the first. I think maybe this should be something more. Sure, this should probably have a name too. Though I'm not sure. This one I'm not sure about. This one I feel like it should be minimized as well. Let's just the application. should be multiple ways to transition to a particular state, I would say. Is that right? Maybe it's not right. Maybe there's only one way to transition to a particular state. Like H, type H, type A, but it's not about the other index. This index is the other letter, and the other letter is the other letter. How do you transition from the previous state to have that other letter? The other letter has to be there. That's the unique combination. Okay, maybe I'm wrong about that. I think what I'm going to do is copy, revert, maybe it should be maybe instead. And then I'll just do comment. Oof. Should I give spacing? Okay, maybe that's right. This should be -1. DP of index to previous is cost plus my distance. Okay, so I think the answer should be going through the last index. So why would I use it? It should be infinitely. I can just find the meaning of the array at the last index, I think. So I think it'd be something like return dp of the last index, just the meaning of that array. See where this crashes. Index got a range. That was a pretty quick crash. Word at index current. Yeah, this is just the end. Wait. Just end. So how would this work? So I typed H. And now the current letter is A. Okay. Maybe in that case maybe in that case it should just be N as the length of this thing. Okay. Ooh. Let's go ahead and just see what this thing gives me for the DP matrix. Should be a pretty big thing. Yeah. So the last thing came up was the settings. Let's go ahead and for every index in range n print and dp of this index. Oops, that should be index n. Just want to give it easier spacing. Okay, so 0, so H is typed with one letter, with one finger, the other finger's is unused. Okay, here, 0 or 2. 0 if I basically, I know that one finger's on the H. If at this point I'm typing A and the other finger's on the H, then that means that both fingers have been placed and there's a total distance of 0 for all that. Or if I haven't moved, I haven't used my second finger, then H typed the A, which means it moved from H to A, which was 2. Okay, so P, so last letter was P. If my other finger's on A, then that means that I typed H, A with those fingers, with that finger, P with my other finger, so it's 2. H, A, P. How did it get 5 there? So index 2, so P, so one finger's at P, the other finger's at H. What it says. That's what it means. The other finger's at H. A, B, C, D, E, F, G, H. So how that occurred? It would have occurred if H was typed 1, and then A and P was typed by the other finger. Is that 5? 1, 2, 3, 4, 5. Yeah, I guess that is 5. So H typed 1 finger's on H, the other one's typed A and P. I guess that's fine. And if one finger typed H, A, and P is 2 and 5, which is 7. So same thing here. Not sure where the 7 came from. This looks like index for P. If I just type P. So the previous and the current are the same. Previous and the current are the same. Okay, so what should have been the smallest? This should have been H, A, H and A. So it should have been like the 2 here. And then this 2 here to type a P, and this 2 here to type this other P. H, A, P, P, and then this, there should be a 6 in here. So A to Y should have been plus. A to Y should have been plus 4. So the last, so it's type Y, and the other letters on P. So this should be 6 right there. So maybe I did need the minimum. did need that. Let's type this in here. This one's a little, feels like this one should be possible to have some other way of getting to this point. But mine is weak. Is weak. Oh, wow. I don't think it's been a while since I coded just based on like I don't even know what this coding is about. This is just like me guessing, stumbling to exit. It's kind of disgusting. This is coding by like intuition and vague understanding, hoping that test cases will work out. And I arrived at some solution, but having no firm confidence in what I did. It's reproducibility, it's explainability, it's completeness, nothing. It's just, this feels like what I have seen or I've done before. And maybe this works out, maybe it doesn't. Who knows? Yeah. Okay, so I feel like there was a step in this process that I tried to just skip over with this kind of optimization with the other. Like there's generally it's going to be 3D. I feel like it's going to be 1D for the index that you're typing for the letter, another dimension for, and like 2 more dimensions for like the combination of previous letters that you've typed or previous locations of your fingers. But then I collapsed it to 1 dimension because one finger is kind of already known to be the previous at the location of the previous letter typed, but that just made things in many ways kind of confusing. But it was in theory a possible thing that I could do. I did it, even though it was far from straightforward. Okay, so I did it. Summary. So I'll summarize this as use dynamic programming to find the lowest distance to any particular state, where state is defined as basically the index of letter to be typed, and comma the other letter, the other fingers other finger's letter / position location. The other finger's letter, where for index greater than or equal to 1, one finger is known to be at the location of the previously typed letter. So the other letter's finger could be some position, some letter other than the previous typed letter. So if the typing happy and your index 1, then your other finger has to be, in theory, your other finger has to be on typed letter, because one finger has to be on H. So if you were typing P, your other finger could be on H. It's not on A, because A is definitely one finger, the kind of primary previous finger. So the other finger is on H, or the other finger is not having typing. But if you're on Y, then the other finger, well, one finger is on P, the other finger is on A, H, or having typing. So that's kind of the logic of the states. And then constructed the DP matrix and initialize the starting condition, which is to say that at the first letter, other finger is on kind of the unknown, unused index, which is index 26, or -1 if you do the wraparound for indexing. Of course, I actually converted minor points. Converted word string array, word string to array of integers, where a is equal to 0, z is equal to 25, etc. And created a helper function. To define the distance between two kind of letter integers, like 0 and 25 for A to Z or something. But that's pretty basic comparatively with find distance function. I did need to create also the locations of locations array, where I can index into locations array for the letter integer value to get that tuple, and then for the tuple of row and column for that position to find the distance. So corrected DP matrix initialized the starting conditions, then iterated over the indices of the word, and perform logic to transition from state to state. So I mean, it's not that much logic. It's not the simplest logic I've ever seen. Previous and current are just the integer values of those letters, right? So for every other position that your other finger could be on, if it can't get to the state because it's infinity, then just skip it. The cost of getting to this state is whatever the DP matrix it has up to the previous one. And then, so at that point, it's either going to be you move the other finger to type the current letter, or you move the previous finger to type the current letter. So if you keep your other finger on where the other letter is, then moving the previous letter to type the current letter. So the cost here plus find the distance from the previous letter to the current letter. And then the other kind of logic there would be if you move this other finger, then you keep your previous finger where your previous finger is, and the cost would be cost this state plus moving your other finger to type the current letter. And then there's one caveat to that would be if the other is 26, which is the other has not been used yet, then if you use it to type the current letter, then that means that your previous finger is still not the previous finger, cost is still because it's just 0 for doing that. Alright, anyways, time complexity lets me say this n squared. N squared is just n. It's like 26 times n. Is of n because that's the simplification of 26 for each letter letter in the word performing, I think it's 26. I guess it's 26 times 26. For each letter in the word performing the transition from that index to the next index, which could involve calculating approximately 6 times 26 combinations of kind of what the other letter is, of what the former of other letter at index minus 1 to other letter at index. It might be better to say O of, let's say, n times k squared, where k is the number of possible letters in the alphabet. Basic complexity is going to be O of Jesus. O of n k, where again k equals the letters in the alphabet. Yeah. In theory, this could be made into O of k, since we technically could collapse the DP matrix into just holding onto the previous and current set of k states. So you don't need the state set index. It's like x0, x1, x2, and so you get past that. So like it'd be dp is just infinity times 27 times 2 for the previous and current, rather than times n. Alright, whatever. Someone in the chat, fix the mic. Voice is sounding kind of mumbling. I just started. Big 3D map of coordinates, and I've seen the hints. DP is fixed. Well, uh, sunny. Hopefully, hopefully the summary was fine. But yeah, turns out it was